Next test, good question. Excuse me. Next test is next Friday. This is a very short module. We did start it before break talking about translation slides. And we had 3 different ways to represent those translations. One was just saying verbally which way it was supposed to move, up or down, how far, left or right, how far. We also had our vector notation. Vector notation had those angled brackets. It looked kind of like an ordered pair, except it had angled brackets on the side. The first number would tell us how far left or right we were going to move. The second number tells us how far up or down we're going to move. And then the third way we had of representing translations was with coordinate notation, where it would have x plus or minus a number. That would tell you the left-right movement, and then comma y plus or minus a number. That would tell you how far up or down it was going to move. Any of those 3 ways would be how it would be represented to you, and then you would have to take that, find the new ordered pairs, and plot those points and graph it. Today, we're going to talk about reflection, and we talked about reflections just a little bit on Friday before we went on break, where we did some reflecting over the x-axis and some reflecting over the y-axis. So that's where I want to start us today. This first one, we are going to reflect across the x-axis. Whatever axis we're going over, that part of the ordered pair will stay the same. So since we're going across the x-axis, the x part of the ordered pair will stay the same. The y will change signs. So looking at this line segment here, we have 2 points. We have point C and point D. What's the ordered pair for point C, where it's at right now? -5, 7. So if we take that and we reflect it across the x-axis, the x is going to stay the same. So x is still going to be -5. The y part of the ordered pair is going to change sign. So what will the y part be? -7. So -5, -7 would be our point C prime. And that would be down here. And then we do the same thing with our point D. What is the ordered pair for where point D is right now? -3, 1. We're going over the x-axis, so x stays the same, y changes signs. So where would D prime be then? -3, -1, yes. -3, -1 would be right here. So here's my point D prime. And then I'm going to send some straight edges back for everybody, but we want to make sure that we are then connecting those 2 points to make our line segment C prime, D prime. All right, straight edges are on their way back right now. All right. I'll give you guys a moment to get that sketched into your notes. And then number 2, we're going to take this triangle GFH. We're going to reflect this across the y-axis. How do you think that's going to be different than when we were reflected across the x-axis? Now it's the y that stays the same. What else do you think would happen? X changes signs, yes. So let's go ahead and write down the ordered pairs for all three of these points, G, F, and H. What's the ordered pair for G? -5, 6. What about for F? 4, 5. And for point H down here? Yep, 2, 1. For all of these, my X is going to change signs. The Y is going to stay the same because we're going across the Y axis. So what would my point G prime be then? 5, 6. Y stays the same. X changes signs. So 5, 6 would put G prime right here. What will F prime be? -4, 5. -4, 5. So F prime is right here, very close to my original G. And where would H prime be? -2, 1 is absolutely correct. -2, 1. So right here is my H prime. And once I get all three of those points plotted, I'm going to grab my straight edge and I'm going to connect those points to make my reflected triangle. It should look like you took that original triangle and you flipped it over. We're flipping it over the y-axis there. So everything flipped vertically, or along that vertical axis, rather. All right. Let's look at number 3. We're going to do a composition in number 3. Does anybody remember what a composition is? We mentioned this very briefly on Friday before break.
Is it when a line flips over a specific? No. Wait, no. Never mind.
That's okay. A composition is where we are going to take 2 or more transformations and apply them to our points. So in this case, we're going to do a reflection across the y-axis first. And after we do a reflection across the y-axis, we're going to take that and then reflect it across the x-axis. But the very, 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 very first thing I need to do is to graph these points up here to get triangle HIJ. H is at -8, -7. So here's my point H. I is at -6, -1. So here's my point I. And then point J is -3, -5. So here's my point J. Take my straight edge and connect all three of those points to make my triangle HIJ. What's going to change and what's going to stay the same when we do this first reflection, when we reflect across the y-axis?
The X is gonna.
That's okay. Yeah. Whatever axis we go over, that's the thing that stays the same. So since we're going over the y-axis, our y will stay the same. And your X is going to change signs. Thank you for speaking up, though. And you got the right idea, absolutely right idea. We just had the wrong axis. Okay, so let's write down what our new ordered pairs are. My x's are all going to change signs, but the y parts of the ordered pairs will stay the same. So what will h prime be? 8, yep, 8, negative 7. Y stays the same. What will I prime be? 6, negative 1. And j prime? 3, negative 5. And then we can go and plot those points. 8, negative 7 is going to be right over here. So here's my h prime. I prime is 6, negative 1. So here's my I prime. And then j prime is 3, negative 5. So right down here is my j prime. Grab my straight edge and connect my points to make my reflected triangle. Again, it should look like you took that original black triangle here and you've flipped it over the y-axis, so it's gone across this vertical axis. Notice everything is a mirror image. It didn't slide, it flipped. All right, then we're going to do our second transformation. This makes it a composition. That's 2 or more transformations. This time we're going to be working with h prime, I prime, j prime. So looking at these points over here, what will change, what will stay the same? Yes, x will stay the same, and y will change signs. And again, we're not going back to those original points. We're going over here to h prime, I prime, j prime. So what will my h double prime be? 8, 7. X stays the same as this one right here in h prime. Y changes signs. What will I prime be? 6, 1. Sorry, not I prime, I double prime. What about j double prime? 3, 5. Let's go plot those 3 points and do our new reflected triangle. 8, 7 is right here. So here's my h double prime. 6, 1 is right here. So here's my I double prime. And 3, 5 is right here. So there's my j double prime. Grab my straight edge and connect those points to make my reflected triangle. So now it should appear that I took the green one and I flipped it across the x-axis. I reflected it across this horizontal line up here into the first quadrant. So far, so good? All right. We can do reflections not just over the x-axis and the y-axis. We can reflect over different lines. So we're going to do a couple with practice on that down here with numbers 4 and 5. Number 4, we want to reflect the triangle across the line x equals negative 2. X equals negative 2, so we need to find negative 2 on the x-axis. And then we need a vertical line through -2. So here's -2 on the x-axis. X equals -2. Well, this entire line right here, all of those points have an x part of the ordered pair that would be -2. Let me make that just a little bit bigger. I want you to go ahead and draw in this dashed line here. To reflect across that line, I don't have a nice little shortcut trick like I do when I go across the y-axis, where y stays the same and x changes signs. When I reflect over a different vertical or horizontal line, I need to count how far away my points are from that line. So here, to get m prime, I'm going to take my point M right here. It's going to stay at the same height, so the y will still stay the same. My x is going to change, though. It takes me from here 2 hops to get to that vertical line. So then I need to go 2 hops on the other side. 1, 2. Right here would be my point M prime. So we reflected it across that line. So where did M prime end up at? -4 is the x part. What's the y part of that ordered pair? -1, yes. -4, -1 would be my ordered pair. Where did we get the -1 from? It's 1 block below the origin. So the y part of the ordered pair for M is -1. This is going to stay the same height, so also -1. All right, now we're going to do the same thing with N right here. Here's N. I need to count how far N is from that vertical dashed line. So 1, 2, 3, 4, 5, 6, 7, 8. Takes me 8 hops to get over there to x equals -2. So I need to go 8 hops on the other side. 1, 2, 3, 4, 5, 6, 7, 8. Thank you very much. And that would put my point right here. Here's N prime. 8 hops to get to the line, so 8 hops on the other side of the line. Where would that put my point N prime then? -10, -2, yes. -10, because we are out to the -10 on the x-axis, and that's always the first number. And then -2, because from the x-axis, we are 2 blocks below that. All right. Now we're going to do the same thing with our point O right here. How many hops to get to that vertical line? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to go 9 on the other side. 1, 2, 3, 4, 5, 6, 7, 8. 9 puts me off my graph just by 1. So we're going to go ahead and draw it in there, even though it falls off the graph. Where would that be then?
-11, -6.
-11, -6. Grab my straight edge and go through those points to make my reflective triangle MNO. So when we went across a vertical line, y stayed the same. Count to find x. Number 5, it says graph both the following segment and then reflect the segment across the line y equals 2. So the first thing we're going to do is take points T and S and graph those points. -1 is right here. So here's my point T. -6, -3 is right here. So here's my point S. And then use your straight edge to connect those. This time, instead of reflecting across an x equals line, we're going to reflect across a y equals line. So we're going to find 2 on the y-axis. Two on the y-axis is right here. And then we're going to do a horizontal line through 2. So like this right here. Whenever we have an x equals or a y equals for the line that we're going to reflect across, we need to go to whatever axis the letter is and find that number. And then we're going to go through the axis at that point. So it won't go the same direction as the x-axis or the y-axis. If it's an x equals, it's going to go the same direction as the y-axis. If it's a y equals, it's going to go the same direction as the x-axis. Right, now just like we did a moment ago, we're going to count. Thank you. This time, my x is going to stay the same. And we will count to find y. So let's do that with our point T first. I want to count to the line, to that dashed line that I drew. So it would take me 1, 2, 3 hops to get to that line. So then I want to go on the other side. 1, 2, 3 hops. So right here is my point T prime. Where did point T prime end up at? -1, 5. And then we'll do the same thing with our point S right here. I want to count from point S to the line. 1, 2, 3, 4, 5. So now on the other side of the line, I want to go 5 units away. 1, 2, 3, 4, 5. Right up here is my point S prime. Where did that ordered pair end up at? -6, 7. Grab a straight edge and connect those points together to make our reflected line segment. It shouldn't look like it moved back and forth at all. It should look like it just flipped up towards the top. It flipped over. Let's take this to the back side. Top of page 4, I would like you to copy this into your notes. In addition to reflecting over axes, x-axis and y-axis, and reflecting over other vertical and horizontal lines, we can reflect across the line y equals x. This is a perfectly diagonal line that starts low on the left and ends high on the right. Or another common line to reflect across is the line y equals negative x. This is another perfectly diagonal line that starts high on the left and ends low on the right. Our rules for reflecting across these lines: if we reflect across y equals x, then the x and y part of my ordered pair are going to flip around the other way. So point A, B, whatever these numbers are for A and B, are going to switch positions and become BA. If we reflect across the line y equals negative x, we're still going to flip the x and the y part of the ordered pair, but then we will change the signs on both of them. It doesn't mean that they have to come out negative. If they were positive, then they'll become negative. But if they were negative, they're going to change and will become positive. They're going to change signs when we reflect across y equals negative x. All right, let's see if we can do number 6. I have my point M, which is 4, negative 7. And I want the new ordered pair, if we take that point and we reflect it across the y-axis. If I go across the y-axis, what stays the same, what changes? Y stays the same, and x changes. X is going to change signs. So what would M prime be then? Negative 4, negative 7. The x changed from a positive to a negative. The y stayed exactly the same. What about if we, instead of going across the y-axis, we go across the x-axis? Yep, x then would stay the same. And y would change signs. So again, I'm going to go back to my original point M, 4, negative 7. X is going to stay the same, but y is going to change sign, giving me what for point M prime? 4, 7. If I reflect across the line y equals x, we wrote this down up above. What's going to happen to my 4, negative 7? Negative 7, 4. This one is going to switch. Negative 7, 4. If we go across the line y equals negative x, it's going to be 7, negative 4. This one we're going to switch and change signs. So flipped around just like the one above it. Instead of negative 7, that would change to a positive 7. Instead of positive 4, that would change to negative 4. All right, so for E and F, I'm going to need to count in order to do this one. So I'm going to draw myself a real quick XY axis off to the side. And I'm going to figure out where my point M is at 4, negative 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So my point M would be about right here. 4, negative 7. For part E, it says we're going to reflect across the line y equals negative 8. Well, that would just be one below this, right? Because my m is at 4, -7. This would be y equals -8. We have to go through -8 on the y-axis. How far away is my point M from that horizontal line? 1 hop. So to get to M prime, I would go 1 hop on the other side. Where would that ordered pair be? -9. What would the x part be? -4, -9. Remember, the x part stays the same if I'm moving up and down. We went 1 hop below the line, and the line is at -8. So 4, -9. Yes. Yes, but it's much more complicated. So yes, there is a way. It's not faster and easier. All right, let's do the last part of this one now. We're going to go across the line. X equals 1. Well, x equals 1 is right here, +1 on the x-axis. So I'm going to draw a vertical line through that. X equals 1. I'm going to have to count how far away I am from that. So my point M right here is going to hop over there. If this is at 4 and this is at 1, how many hops would it take? It's going to take 3 hops to go from 4 backwards to 1. 1, 2, 3 hops here. So I need to go 3 hops on the other side then. 1, 2, 3. So my new M prime would be over here. It took me 1 hop backwards to get to the y-axis, and then I went 2 more hops backwards. Where would this M prime be then? Draw all the grid lines in. So here's one more. There's that. That's 2 hops behind. No, we only went 2 hops behind. -2. What would the y part be? -7. Yes, sir.
Can I clip my nails, please?
Yes, you may. -2, -7. If you guys have questions like that on the test and there's not the grid marks, I have little graphs on extra pieces of paper that I'm happy to give you guys so that you can draw it out and count the grid lines. So if you run into that problem, I'm more than happy to help with that particular piece. All right, let's look at number 7. Given the graph to the right, reflect triangle GFH across the line y equals x. The line y equals x is this perfectly horizontal line right here. Goes from the lower left to the upper right. It passes through the points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, where the x's and y's are the same. -1, -1, -2, -2, -3, -3, -4, -4, -4, -5, -5. This is our line y equals x, where the x's and the y's are both the same in the ordered pairs. All right, let's write down what are the ordered pairs for G, F, and H right now. Where is G? What is the ordered pair for G? -4, +4. What about F? Other way around. Remember, we do the left, right first, and then the up, down number. So -1, +4. And then what about for point H? -5, 1. To go across the line, y equals x. What did we write down at the top of the page? Switch. Yes. Switch x and y. So what would G prime be then? +4, -4. We take the x and the y and we flip them around. +4, -4 would be right down here. So here's G prime. What would F prime be? +4, -1. So 4 to the right and down 1. Right here would be my F prime. And what about H prime? Where would H prime be? +1, -5. So 1 to the right and down 5. Right here would be H prime. Grab your straight edge and connect those points to make triangle G prime, F prime, H prime. All right, we are almost done with this. Let's do another where we reflect across a line that's not an axis and it's not perfectly horizontal or vertical. We're going to reflect about the line x equals -1. So when we have an x equals or a y equals some number, we're going to find that number on that axis, find -1 on the x-axis. So that would be right here. And then we need to go through the x-axis. Which is going to make it vertical. So I'm going to go up and down through that. And this is the one where we need to count. G is right here. I'm going to count over to that line. 1, 2, 3, 4. So then I go on the other side. 1, 2, 3, 4. Right here would be my G prime. What would that ordered pair be? It's 3, 6, yes. We hopped 4 places, but we were 1 space away from the axis. All right, now we're going to do the same thing with H. How many hops to get me backwards to the line? 1, 2, 3. So then on the other side, 1, 2, 3. Put a point down. Here's H prime. Where's H prime at? -4, 1. And then F prime. Right here is F. How many hops to get to the line?
5.
1, 2, 3, 4, 5. So on the other side, 1, 2, 3, 4, 5. Right here is my F prime. What would that ordered pair be? -6, 5. Then we're going to grab our straight edge and connect those points to make our reflected triangle G prime, H prime, F prime. All right, number 9, we're going to go across the line y equals x again. So all the x's and y's will match. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. It goes through 0, 0. -1, -1, -2, -2, -3, -3, -4, -4, -5, -5. My line y equals x is a horizontal line where the x's and y's match each other. And what was our rule for this one? Switch x and y. So we need to do that with our point V. What's this ordered pair right now? Where is point V? 2, -5. So we're going to take that and switch it. So that would become -5, 2. Puts me right here. V prime. Where is my point W right now? 4, -1. So we're going to go and flip that, switch it around. -1, 4. -1, 4 would be right here. So there's my W prime. What's the ordered pair for where x is sitting right now? Close. 2, -2. So then we switch that and it becomes -2, 2. -2, 2 is right here. Here's my x prime. And then I want to connect those to make my reflected triangle. All right, very quickly before we switch over to the announcements. Orientation of a triangle is preserved with reflection. Is that true or false? Orientation is how the points are related to each other. So like right here, point W is the one at the very, very top of this figure. Is point W...
No. Wait, well, in this case, yeah, but not the same way.
Yes, not the same way. X is to the left of it here. X is still to the left, but not as far left. Here it was 2 units left. Here it's only 1 unit left. So orientation is not preserved. All the points move the same amount. No. Distance of the object from the axis of reflection is preserved. Yes, the axis of reflection. We keep that distance the same. If we go 4 on one side, we go 4 on the other side. Sign of x and y coordinates always stays the same. No. And last one, angle measures of the triangle are preserved. Did my angle measures stay the same? Yes. So we only had 2 things that stayed the case here. All right, guys. Homework that you guys got before break is due tomorrow. The front side is all the translations, the sliding. The back side is the reflections, what we learned how to do today. If you need another copy of that homework, it's this very bottom paper right down here in this red organizer.